Welcome to clickmyproject.com. Let's see about the process for a new ECG beat clustering method. So it's based on the kernelized fuzzy cmeans. So by use of hand colony optimization. So in this process, the kernelized fuzzy cmeans algorithm is used to improve the clustering performance. So first we include the input dataset for the heartbeat datasets. So are abnormal. So from this we can find out the normal values and the as well as the high values by use of fuzzy key means. So thus the newly obtained datasets is more likely to be linear separable. So to further improve the clustering form performance, we use the classifier. So it's stored in the database. By use of this, we can use the transformers as the Fourier transform, D4 transform, and the complex method. So then by the filtration, we use the mean filter and the median filter. So mean filter means it's used to filter the normal values, and median filter is used to filter the high values. So in the both features of the extracted of the beat type, the training sets is formed. So after several experiments, it is observed that the proposed method outperforms the traditional fuzzy of algorithm. Then it will be a kernelized and datasets will be normal. Then it will be predicted to the fuzzy means. Let's see how the flow of process. So in this process, first we load the dataset from the input. So it is the signal waveform. So from that we can classify. So classification means the normal values and high values, it will be separated. Then by using this, it will be create a transformers. So by the operation of transformer, it will be used to do four methods. First is the Fourier transform. So Fourier transform means the, so you can calculate the normal values. Then the D4 transform is the check whether it is low or below low. So then complex method. So complex method is used to find out high value. So from this we can filtrate from the normal value and high value. So then the filtration is gone. So filtration is the means of mean filter and median filter. So here the median filter will be calculated by the high value by taken by the is a high peak range value. Then the mean value is the taken from the normal value is set to the 0. So from this we can classify many forms of class of filtration. So then the source separation. So in source separation, it will be calculated by the form of Fourier and DWT and Fourier. So like this we can find out the, let's see the execution of the process. So right click the home.java and run file. So the welcome screen will be appear as for the new ECG beat clustering that based on kernelized fuzzy. Click enter to continue the process. Here this is the configuration page for enter ECG. So in this section we have different types of operation. First is the configuration. So configuration means we can select the data set and the signals will be applied. So then in operation side it's a graph and the transform, and then a filter it be a median filter and a mean filter. So we can now see about as a one by one process. So first we can choose the configuration. So select the dataset from the folder. So this is the dataset for the given ECG. So the file extension is the .edf. So the signals will be loaded here. So we can choose any one of the file, and in the operation we have to choose the where we have to place. So click graph 1 and click add to. So now click the draw graph. So the graph will be formed in the graph 1. So again we have to choose the another one type of signal. So it plays in the graph 2. So click draw graph. So it will be a difference between the both graph. Then by using the operation transform, so we have seen about one by one transform. First is the horror. So in which graph you have two changes the transform. So by clicking the graph one, so first operation is the horror transform. So click transform. It will be a form of horror. So it's available between the normal data set. So the from the 0 is the normal, then it's above means is a maximum, and below is a minus. So then the Fourier transform. So click transform. So the Fourier transform will be a normal wavelet between the 0 points. So then D4 transform. So D4 transform is formed by use of the like this. So it's a filter overall the process. Then the complex filter. So complex filter is same as the Fourier transform. So because it's also the normal value to fixed rate. So now the wavelet is formed, but it's a minor process. So then by clicking the filter, we can take the normal values by use of filter. So now the filtration is process. This is the filtration of a normal value. So click view. So this is the normal value of the given data sets. So every data set will become a normal value, so between a dynamic. So then the complex method. So complex method is the high position range of the maximum value. So the processes are being calculated. So because the data sets is large, so the complex is loading. So is higher than the filter. So now the high value is calculated. So click view. So this is the high value for the given data sets. So it's every data set will be calculated. So in this form, so there is a maternal ECG with given BPM of data field. So then the fatal heartbeat. So fatal heartbeat is a range of 14.64. Then maternal is the field of 21. So from this board we have to filter it. So then the operation is used for the filters. So the click the median filter means it will be a median filter to the show the normal value of the process. Then the mean filter. So mean filter is the mean value. So it can be as a green. So this is the both filtration will be applied here. So then we have to choose what data set we have choose means EEG P4. So take that data set from this source separation. So now click the complex domain, and this component is the for used to draw the graph. So we have to set the fast ICA. So click it, and it will form a complex domain between the fatal and maternal ECG data sets. So it shortly will be calculated. So this is the graph for maternal and fatal data sets for the given blind source. So from this we can find the how it's maximum or how it's normal. So these are the normal with below normal. So it's a overall process. Then this is the high peak value for the high data sets. So like this we have calculators are different for Fourier domain, DWT pre-filter and post-filter. So Fourier domain is like this. So from the Fourier domain, so we can find out the normal values or below the normal. So in this graph, so we have choose as a normal data sets. This will be clearly calculated. So by the use of peak as well as the fatal heartbeat is a very low process between them. So then the DWT pre-filter. So click fast ICA. So this is the DWT pre-filter. So pre-processing before the Fourier domain. So like that DWT post-filter. So the post-filter is the after the Fourier domain. What will be happen like the signals is the it will be formed. So this is the operation for the blind source separation. So after that we have choose the spectrum. The spectrum is calculated for the maternal ECG. So this is the final spectrum value for maternal error. So this is the overall process for the ECG. So from this we have find out the normal data and high data by use of classifier, so between the filter and the complex method. Thank you.